which is a glass tube. Then we have the liquid whose viscosity you are going to measure. And we have here our water bath and pellet balls or steel balls. So in our dry run a while ago, we found out that the steel balls would require about 1.5 seconds to fall down to the bottom of between the two fiduciary lines. So we opted that we would rather use pellets because it will require much more time than you can see clearly and dili magkara it measures the time. So here is rehearsal for our demonstration.
In your figure, there's a stand for your...
Okay, mag-agad lang.
So because movement with...
So instead of a stand, sa among water bath, kinami cork, which is so there you insert. So in the experiment, we are going to measure the viscosity. We're going to determine the dependency of viscosity with temperature. But for demonstration purposes, we're just going to use ambient temperature. So if you want higher temperatures, obviously we need a heater.
Can you have constant temperature with just that?
Dapat ma'am na ice clear sa the gamit na clear.
The sugar will not make it constant. It should be constant water bath. A constant temperature water bath or a thermostat.
The heater has a thermostat. The heater has a thermostat.
The heater can maintain the temperature.
So first, we're going to pour the oil into the tube, and then what you have to be careful with is that there must be no bubbles inside the tube. If there are bubbles, then you have to repeat this step again and again, or you can heat it to relieve the air bubbles. And then you must also fill the tube to the brim so that you can achieve the terminal velocity right away.
Swirling cloud.
You know what to do when you insert something in a fork, you know, to be twisting and you at least lubricate.
So as you can see, supposedly the water bath should be above the fiduciary line, but ang cork sa diri kay natangtang man siya. And then our cork can only fit this distilling flask. So amo pa ni siya kusbon so that we can have a flask wherein there is no tube at the side or dili mag-spill. And then another important equipment you need is a timer or a stopwatch. So, in conducting the experiment, you're going to measure the time it takes the pellet ball to travel from between the first pair of fiduciary lines to the next pair of fiduciary lines. And then when dropping, you must not drop it abruptly. You must kanang guide it from the to the brim until makuha gid siya. Because it will gain kanang a certain speed if it will travel through air. So, assuming we have ambient temperature,
Sure. Stop.
Total time 9.34 seconds.
so you can see now, the time it took for the bullet balls to travel is 9 seconds, 9.34 seconds. So that is why we opted it, so that we could clearly see the ball traveling downwards. And then after that, you use Stokes' law to measure up to have the calculated viscosity of your oil, and then base your error on the kind of theoretical viscosity of olive oil.
Vamos support bisa ng team viscometer.
So there are easy way to measure some of physical properties. And viscosity is one important. It's supposed to be, you can have it in your picken, picken lab, or viscosity. Because we have a Osgood viscometer, and we also have sarang sa MA lab, sarang na viscometer sa lab, dito, MA, to measure viscosity. So there's another viscometer.
Also, before you do the experiment, you have to measure also the density of your olive oil. We measured it before, and then using the viscometer, and we had 0.926 grams per
What is the difference from the standard European?
The vertical density of olive oil is 0.914 grams per
And how about it?
0.926.